I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will discuss the topic on logic gates for the course Digital System Design. So, a logic gate is an electronic circuit which makes logical decisions based on the combination of digital signals present on its inputs. And the most common basic gates are a AND gate, NAND gate, OR gate, NOR gate, NOT gate, XOR gate, XNOR gate. Here, in these given gates, and NAND gates are complement to each other. OR and NOR gates are the inverse gates, and XOR and XNOR are the inverse of each other. And the first gate we are going to see is the AND gate, which performs the multiplication operation, and it gives high output only if all its inputs are high. And in order to represent AND operation, we use dot. And for example, if we take two variables a comma b, the AND operation of a comma b is given by a dot b. And the truth table for two input AND gate is given here. If both the inputs are high only, the AND gate gives high output. Otherwise, the output of the AND gate is 0. And the right side diagram is the symbol of AND gate. There are two inputs AND and A and B, and its output. This is two input AND gate, and the output X is equal to A and of B. And for example of AND gate is the burglar alarm. So in this alarm, if both the person sensor and alarm switch are on, then only the burglar alarm is on. Otherwise, it is deactivated. So next is OR gate. The OR gate is an electronic circuit that gives a high output if one or more of its inputs are high. So at least if any one of its input is high, it gives high output. So here a plus sign is used to represent this OR operation, and this performs addition function. So the truth table given at the left side is A, B are the inputs, and its output is A plus B. So OR gate OR symbol is represented by the symbol plus. So according to our logic, if any one of the input is high, the output is high. It gives 0 value if all the inputs are 0 only. And next is the symbol is given at the right side. A and B are the inputs and X is the output, where X equal to A or of B. And an example for OR gate is the doorbell. So in the doorbell, for example, consider both the front door bell switch and back door bell switch is connected. So if any one of the switch is on, the doorbell is activated, or doorbell rings. So this is the example of OR gate. So next is a very important gate called NOT gate. NOT gate produces the inversion of the given input, and it is also called as inverter. So if the input variable is A, the inverted output is known as NOT of A, and this will be represented by A complement or A over bar. And the output is simple, the truth table is simple. If A is 0, A bar is 1. If A is 1, NOT gate input is 1, its output is 0. And the symbol is triangle symbol, and NOT gate is having only one input and one output, and where the output X equal to NOT of A. And example of NOT gate is the temperature sensor is connected to central heating. So temperature sensor is at the input side, central heating switch is at the right side. So the threshold value is taken as 20 degrees Celsius. So if the temperature detector shows above 20 degrees Celsius, then the central heating is switched off, otherwise it is on. So this is the example for NOT gate. So next is the NAND gate, which is the inversion of AND gate. So the output also inverse to the AND gate. We know the AND logic. According to AND logic, if both the inputs are high, then the output is high. But in the case of NAND logic, if both the inputs are 1, the output is 0. Otherwise, all the outputs are 1. And a NOT gate is NAND gate symbol is like a AND gate symbol, but in the front there is a bubble. So this bubble represents it is a NOT of AND operation. Now the activity. So next is NOR gate. NOR gate is the complement of OR gate, that is not of OR gate. So according to OR gate, we know if any one of the input is 1, its output is 1. But in NOR gate, if all the input is 0, only if it gives 1, otherwise the outputs are 0. And another important gate is XOR gate, or it is called as exclusive OR, and this is a gate which give a high output if either but not both of its inputs are high. So it is encircled plus sign used to show the XOR operation. So the left side is the symbol of XOR gate, similar to OR gate, but with the another curve in the front side. So AB is the input, C is the output. So C is equal to A plus B. So if we observe the logic diagram, logic table or truth table, so according to XOR gate, if both the inputs are same, then the output is 0. So in XOR gate, if we give same input at its input side, we get 0 at the output. Suppose if we give indifferent input at the input side, any one of the input is low and another one is input is high, then the output is high. So this is the logic of XOR gate. And its inversion is called XNOR gate, opposite to XOR gate, and its symbol is dot, represented by dot with a circle. And XOR gate symbol is plus with a circle. XNOR gate is dot with a circle. And its output truth table gives the complement to XOR gate. So here if both the inputs are same, then it gives one output which is inverse to XOR gate operation, and for indifferent inputs XNOR gives 0 value. Assessment questions: logic gate, application of NOT gate we have seen with temperature sensor example. Logical operation of XOR gate, we have seen the logic. Thank you.